We're going to continue our conversation in Chapter 3 on facility design and construction. Here we go. So in our conversation last time, we discussed the feasibility study. One of the means of conducting a feasibility study is looking at and estimating costs and budgeting. The costs of a constructed facility to the owner include both the initial capital cost and the subsequent operation and maintenance costs. Each of these major cost categories consists of a number of cost components. Pro forma means for the sake of form or as a matter of form. When it appears in financial statements, it indicates that a method of calculating financial results using certain projections or presumptions has been used. Pro forma financials are not computed using generally accepted accounting principles or GAAP, and usually leave out one-time expenses that are not part of normal company operations, such as restructuring costs following a merger. Essentially, a pro forma financial statement can exclude anything a company believes obscures the accuracy of its financial outlook and can be a useful piece of information to help assess a company's future prospects. Pro forma is, in Latin, as a matter of form or for the sake of form, and it's a method of calculating financial results using certain projections or presumptions. And it may not necessarily be GAAP compliant, but it can be issued to the public to highlight certain items for potential investors. They can also be used internally by management for aiding in business decisions. It is illegal for publicly traded companies to mislead investors with a pro forma financial result that do not use the most conservative possible estimates of revenue and expense. So you want to be very careful with that. There are two kinds of costs. There's fixed and variable. Fixed and variable costs impact the business in different ways, but both are important in making the business profitable. Fixed costs are costs that are independent of volume. These fixed costs tend to be costs that are based on time rather than the quantity produced or sold by your business. Examples of fixed costs are rent and lease costs, salaries, utility bills, insurance, and loan repayments. Some kinds of taxes like business licenses are also fixed costs. Since you have to pay fixed costs regardless of how much you sell, you should be careful about adding fixed costs to your small business. Fixed cost is often called overhead. Your variable costs are costs that change as the volume changes. Examples of variable costs are raw materials, piece rate labor, production supplies, commissions, delivery costs, packaging, supplies, and credit card fees. In some accounting statements, the variable costs of production are called the costs of goods sold. Our construction project includes the expenses related to the initial establishment of the facility, land acquisition, including assembly and holding and improvement, planning and feasibility studies, architectural and engineering design, construction, including materials, equipment, and labor, field supervision of construction, construction financing, insurance and taxes during construction, owner's general office overhead, equipment and furnishings that are not included in construction, inspection and testing, the operation and maintenance costs in subsequent years over the project life cycle, including the following expenses: land rent, if applicable, operating staff, labor and material for maintenance and repairs, periodic renovations, insurance and taxes, financing costs, utilities, and owner's other expenses. The magnitude of each of these cost components depends on the nature, size, and location of the project, as well as the management organization, among many considerations. The owner is interested in achieving the lowest possible overall project cost that is consistent with its investment objectives. It is important for design professionals and construction managers to realize that while the construction cost may be the single largest component of the capital cost, other cost components are not insignificant. From the landowner's perspective, it is equally important to estimate the corresponding operation and maintenance costs of each alternative for a proposed facility in order to analyze the life cycle costs. The large expenditures needed for facility maintenance, especially for a publicly owned infrastructure are reminders of the neglect in the past to consider fully the implications of operation and maintenance costs in the design stage. In most construction budgets, there is an allowance for contingencies or unexpected costs occurring during construction. This contingency amount may be included within each cost item or be included in a single category of construction contingency. The amount of contingency is based on historical experience and the expected difficulty of a particular construction project. For example, one construction firm makes estimates of the expected cost in 5 different areas: design development changes, schedule adjustments, general administration changes such as wage rates, and differing site conditions for those expected, and third-party requirements imposed during construction such as new permits. Contingent amounts not spent for construction can be released near the end of construction to the owner or to add additional project elements. Costs can generally be divided into 2 categories: hard costs and soft costs. Hard costs are those associated with the physical building construction, while soft costs are intangible and are typically associated with the planning, permitting, and financing of a construction project. So your hard costs include construction labor and materials, wages for workers physically doing work on the property, and purchase costs for all relevant materials, concrete, wood, steel, insulation, glass windows, and more, and landscape costs. Typically, those are costs for trees, grass, mulch, fertilizer, flowers, bushes, and any other landscaping elements. Site improvements such as paving, walkways, gazebos, permanent or fixed benches, outdoor furniture, and other exterior improvements. And utility installation, your electrical installation, plumbing, water, sewer hookup, etc. The interior finishes, the wallpaper, paint, trim, flooring, and HVAC. So full installation of heating, ventilation, and air conditioning systems. Your life safety systems, your fire alarm systems, sprinkler systems, fire escapes, and other related systems. Hard costs can vary, but are often more expensive in areas with colder climates, as buildings may require additional insulation and slightly different designs to accommodate potential snow and ice accumulation. Contingencies are also required at the final estimation. These usually come out to around 5 to 10% of total costs for new construction, or between 15 to 20% for renovations. Soft construction costs are all costs that do not involve the physical construction of the alteration of the property. Some of the most common examples of soft costs include architectural planning and engineering fees, legal fees, permits and taxes, property and construction insurance, movable furniture and building equipment, such as lawn chairs or fire extinguishers. Location for your sports complex is one of the most important things, if not the most important thing you'll do for your complex's success. And while there are many factors you'll need to take into account in order to thrive, there are none bigger than affordability and the convenience of your location. Like any big business move, you should have a thorough and detailed plan in place before making any big decisions. First, you'll want to create a mission and decide what the objective is. In this case, it's choosing a location for your sports complex. Next, you should identify what kinds of products and services you will offer and who your target customer will be. Then it's the competition and money. Identify who your competition is and detail how you will make money. While you won't have specific information yet, especially monetary figures that pertain to the sports complex, use researched and estimated numbers to ballpark figures that you can shoot for. The cost of space is absolutely vital to your sports complex's success. While you want to have a nice place to call your own, you also want to be realistic, as choosing a space that strains you on a monthly basis can become a burden financially, especially during the initial months where you may not be turning that much of a profit. Choose an area of town or campus. You want to choose a location for your sports complex based on a few things, chiefly among them being the location of your competitors in areas of town that are popular for your target customer. Once you've mapped out these areas, you'll likely have a small list of possible locations. Go ahead and visit each location to get a better feel for the area and highlight the ones you could realistically see yourself at. Additionally, you should keep in mind that picking a location for your sports complex is a permanent decision. If you become unhappy with where you're at or things begin to take a turn for the worst, it's not as though you can pick up shop and move across town. Spend some time evaluating the pros and cons of each location before making a decision. Look for an actual building. Identify the difference between how much space you want and how much space you need, and then focus on the latter. To properly determine the amount of space you'll need, highlight all the things you want to implement in your sports complex. Then see if you can use the same space for multiple purposes. Doing so will allow you to properly evaluate how much space you'll actually need while still being able to provide the services you want to offer. Site factors such as multiple entry and exit points, traffic lights, and dedicated turn lanes are extremely important. There are two important reports that should be reviewed prior to acquiring land. A topography survey locates all surface features of a property and depicts all natural features and elevations. In essence, it is a three-dimensional map of a three-dimensional property showing all natural and man-made features and improvements. Specifically, it shows their location, size, height, and any changes in elevation. Topographic surveys, also known as contour surveys, may be required as part of a real estate transaction, civil engineering, design, and construction projects, including new construction, remodeling projects to existing structures, utility design, and the road or bridge design or improvements, and grading or drainage projects. Topography surveys are required by many local government bodies to determine the existing conditions and elevations of a site. Together with a boundary survey, topographic surveys are used by architects and engineers to create accurate and appropriate designs based on existing conditions. A geographical report indicates soil conditions that dictate what materials are necessary to support the foundation for the proposed building, as well as provisions for drainage of surface and runoff water. A geotechnical report will be necessary to determine the various characteristics of the soil and if it is suitable for your building plans. A professional soil engineering service can help with either a residential or commercial project. The findings in a geotechnical report will then be used by the contractor during the designing, construction, and completion of a project. Even when not required, this report can help reduce design and construction. The geotech report then offers an analysis of the chemical and geotechnical qualities of your soil. The findings of a geotechnical report should include general information on identification of the type of soil, the strength and density of the soil, any organic material or contamination present, groundwater and soil compaction, foundation design recommendations, seismic design factors, and solutions for any foreseeable problems. Most importantly, with this report, there will be findings of the type of soil present on site and if it's capable of supporting the proposed structure. Reports will provide a description of the site condition and geological data, as well as provide appropriate recommendations for site preparation, drainage control, and any conditions that might affect the project. Once all geological elements of the site are identified, then the civil and structural engineer can use the geotech report to move forward in designing the appropriate foundation and structure. If the geotech report indicates bad soil, the soil report is used to assess the safety of the planned structure. But what happens if the soil is not acceptable? The design engineer uses a geotechnical report to see if the conditions of the soil are capable of supporting the structure. Both the engineer for the project and the soil technician are looking to see if the soil allows bearing pressure and the possibility of settlement of the foundation. If the geotech engineer finds that the soil conditions do not meet the necessary structural support, then they will make the appropriate suggestions on how to fix the problem. Some possible solutions may include draining groundwater, installing wider or deeper footings, alternate forms of cement to counter corrosive effects, fixing the slope of the land to prevent structure sliding, or replacing pockets of bad soil with an engineered fill. The geotech report will be specific in its recommendations for building a safe foundation. It is important to then share these recommendations with the structural engineer and building inspector working on the project. By defining the components for the site schematics, a framework is established for the design elements to commence. The contract with the design firm must address that the facility will be designed based on the established budget. The design process is how a construction project is developed and analyzed in set stages. This process usually is broken down into 7 phases to provide order to the project by identifying periods of review, creating a structured release of design information, and determining the natural stages of invoicing. The construction of a building is complicated, heavily regulated, and expensive, and general contractors don't want to revise the architectural design once the project breaks ground. After the project is completed, there's little that can be done without demolishing the structure and starting from scratch. That's why the architectural design process is so important. It organizes the management of the project and offers clear communication on its design intent. The phases of the architectural design process allows the production information to be efficient and transparent to reduce risks that could result in costly and timely delays. The design process is made up of 7 phases. The pre-design, schematic design, design development, your construction documents, building permits, bidding, and negotiation, construction administration. These phases put realistic project deliverables and deadlines in place. Your pre-design is often referred to as the programming phase, which kicks off the architectural design process. At this stage, the architect works with the client to understand the plot of land on which the project will take place. They also discuss if there are other structures already on the site and what the client wants for the building. They're commissioning. This means the architect needs to conduct research and collect information. Some things they must know are local zoning and land use restrictions, project scope, client desires, scale, surrounding buildings, neighborhoods, site conditions, building codes, and more. After this, they'll brainstorm, sketch, and model various design ideas. The schematic design, you want to develop the designs and present them to the client. This means developing a design proposal. Architects will create site plans, floor plans, and building elevations. Also necessary are the structural, mechanical, electrical, plumbing, and heating, ventilation, and air conditioning, or HVAC systems. At this point, you'll want to show your ideas to others and get their feedback. Architects meet regularly with their clients to show them the drawings of different variations to help everyone decide on which design is best. Disagreements are reduced if the architect takes the client's needs into account when designing. After the meetings with the client, the architect analyzes the feedback and makes changes. It's always good to make changes at this phase in the design process to avoid adding costs and potentially delaying the construction schedule if done at a later date. This process of meeting and revising will continue until the design is agreed upon by all parties. And the design development, now that the client is happy with the design, it's time to create a more detailed plan. Those details include the placement of doors and windows and any adjustments to the building form. At this stage, a structural engineer will join the design team to help come up with more accurate estimates for the project. The exterior and interior finishes are then presented to the client and materials. Fixtures and other finishes are discussed. There will be a back and forth with the client, often determined by costs, which will lead to both sides having to compromise. However, at the end of this stage, the building's exterior layout and dimensions are finalized and most of the materials have been chosen. There might still be some minor changes to the building design. With your construction documents, the design services move into working construction drawings. Out of all of the phases, this one tends to take the most time. It's important that architects make sure their designs are well planned for execution. The construction project documents also must be approved. It's possible that an in-house construction contractor will join the development team during this phase of the architectural design process. At this point, the required drawings for the permit set and the construction set are needed. The building permit set is delivered to the permitting authority and can take a long time to approve, so it's advisable to get this done first. The construction set has the details and dimensions of the design for the builder to use throughout the process. Building permits. The city or county will review the building permit set and check if it's structurally sound and follows local zoning laws and building codes. This process is imperative to avoid dangerous mistakes for which the architects, builders, and property owners can be liable. It's also illegal to commence construction without first securing permits for the job. The time to pull permits for the construction project can vary. Smaller construction projects might only take a couple of days, especially if they're simpler. But larger, more complex, or historical construction projects can take substantially longer, taking months versus days. In the bidding and negotiation phase, this refers only to architectural firms that aren't building the project themselves. The bidding process is when architects contract with the construction company that will do the actual construction. The process is expedited if permits have already been pulled. The architect will advise the client when bids come in to find the best fit for the project, including qualifications and costs. This can be done through negotiated bids where builders go through construction documents and review materials and schedules. Keep in mind that sometimes the client already has a construction company in mind for the project. A competitive bid process is when the architect looks over the local construction companies and their past projects. Then the bidding process starts and construction companies will compete for the job, a process that usually takes 3 weeks. Quality, cost, and experience are considered when choosing the winning bid. In both bidding cases, the winning construction company will contract with the client, not the architect. In the construction administration phase, this involves the architect frequently visiting the construction site to answer questions and deal with issues that arise. Having access to the architect is one way to avoid costly delays. The regularity of the architect's visit depends on the size of the construction project, and it could be weekly or monthly. The construction crew is in charge of the development of the project from this point on. This phase will last as long as it takes to complete the construction. Schematic design phase can help you create the early stages of your site plan, the floor plan, elevation drawings. Before construction, your architect or project team will map out a schematic design to help flesh out your building or project's basic design concepts. These rough construction drawings will help indicate the spatial relationships between your building features and let you visualize your workspace and facility. Schematics should include the complete description and location of all building code elements, such as the HVAC system, plumbing, and electrical system. However, schematic designs are only a basic layout to communicate a design scheme to the owner. These designs do not include additional information like special features or specific interior design elements. Material selection is an ordered process by which engineers can systematically and rapidly eliminate unsuitable materials and identify the one or small number of materials which are the most suitable. Material selections are confirmed and implemented into drawings. Your drawing production and attainment of permits can take up to about 8 to 12 months. Construction cannot commence without your permits, which can lead to work stoppage and delays. So permit attainment varies by local code officials, but usually requires a site layout plan. The construction process, sometimes called the construction phase, is the physical process of building, landscaping, and refurbishing, plus all the associated activities such as demolition, site clearance, administration, and so on. Construction works are typically carried out by contractors, although in the contractor may be referred to as builder and contractor, and may appoint subcontractors and other supplies to carry out some or all of the works. The process may start following a procurement phase or process, with handover of the site from the client to the contractor and end with handing back a completed project to the client. It does not include pre-construction activities such as preparation of the brief forming a design team or design and so on, although these activities may be carried out at the same time as construction. The following processes can form part of the construction process. The mobilization. This refers to the activities that occurred that should be carried out after the client has selected the contractor, but before the contractor commences work on site. It is a preparatory stage during which the majority of activities are managed by the contractor. Demolition. as the most high-risk activity in the construction sector. The essence of safe demolition lies in efficient risk control, environmental management, and careful planning. The CDM regulations have provided a platform which the industry should adopt best practice, demanding written plans of work for demolition, even where a project is not notifiable. Clients and their professional advisors play a vital role in safe demolition and must allow sufficient time for planning the works, procure an appropriate contractor to carry out safety and environmental audits, provide sufficient information to a good standard. The site clearance, the process of site clearance is generally undertaken as part of enabling works carried out to prepare a site for construction. It involves the clearing the site to allow other remedial treatment or demolition works to take place before the actual construction work begins. And it involves clearing a site of any machinery or equipment, unwanted surplus materials, rubbish, and so on. Site clearance may also involve clearing away vegetation and surface soil and leveling and preparing the ground for the planned construction work. Care should be taken to ensure that there are the correct approvals in place, particularly for trees which may be protected. A site waste management plan may be prepared before site clearance begins. This describes how materials will be managed efficiently and disposed of legally, explaining how the reuse and recycling of materials will be maximized. All types of waste present on the site must be removed safely and efficiently. If there is any contaminated waste or potentially hazard substances such as asbestos, professional disposal experts may be consulted to safely handle them. Site clearance might be carried out as part of the main construction contract, or it may be carried out in advance of the main contract. It might be part of a wider contract including other enabling works or facilitating works such as demolition works, soil stabilization, services diversion, constructing access roads, and so on. Erection of hoardings or welfare facilities. As a hoarding is a temporary structure of solid construction erected around the perimeter of construction sites to shield them from view and prevent unauthorized access. It is an important component in ensuring health and safety for site workers, visitors, and the general public, and also be part of a site security system to prevent theft and vandalism. The Health and Safety Act at Work, etc. The Health and Safety at Work Act in 1974 requires that employers take reasonable steps to ensure the health and safety of persons other than their employees, which implies a duty to ensure people are safe from activities on construction sites. In addition, the Construction Design and Management Regulations, or the CDM regulations, require the prevention of access by unauthorized persons to construction sites, and that where necessary, in the interest of health and safety, a construction site must, so far as is reasonably practicable and in accordance with the level of risk posed, comply with either or both of the following: have its perimeter identified by suitable signs and be arranged so that its extent is readily identifiable or be fenced off. The principal contractor must take necessary steps to prevent access by unauthorized persons to the construction site. And contractors must not begin work on a construction site unless reasonable steps have been taken to prevent access by unauthorized persons to that site. Principal contractors should liaise with contractors to define the site boundaries using suitable barriers and take steps to ensure that not only authorized access the site do so. For projects involving only one contractor, the contractor must do whatever is proportionate to prevent unauthorized access before starting work on the site. Special considerations will be required for sites that have rights of way through them, other work areas next to them, occupied houses or businesses next to them, children or vulnerable people nearby. There may also be conditions attached to a planning permission setting out specific obligations in relation to the site perimeter. Perimeter hoarding provides a system for controlled access. Turnstiles, security gates, and guards can be used to ensure only authorized personnel can enter. In addition, hoarding might be used to separate different functions within the site. For example, creating a barrier between traffic routes and pedestrians. Hoardings or fences are recommended as being a minimum height of 2.4 meters and high security fences at least 3 meters. Flat-sided hoardings are more difficult to climb than fencing and prevent viewing of the site interior. Where fences are used, the type selected should not help climbers by offering hand and foot holds. Angled extensions on top of hoardings might make climbing difficult and can reduce problems with material, including litter being thrown over the hoarding and potentially damaging materials or injuring site workers. Intruders may also attempt to burrow under a boundary. Placing hoardings along existing concrete surfaces can deter against that. Hoarding can also help make sites less accessible and more aesthetically pleasing to people living and working in close proximity, and can minimize disturbances and improve privacy both for the general public and for the workers on site. Hoarding can be a temporary or long-term installation and may be freestanding or built into the site. It is important that it is structurally stable, as it can be exposed to strong wind loads or impact. It can be a modular system or an installation and can be made using a wide range of materials such as steel, timber, or plywood, which may be usable or disposable. Hoarding can include barriers, gates, viewing windows, areas of fencing, and so on, and may be used to display warning and information signs. Another consideration is insurance. Builder's risk insurance, also called course of construction insurance, is property insurance that protects buildings while they are under construction, either during a remodel or new construction. It helps mitigate the risk of certain damages while a project is in the construction process. It can be purchased by the project owner or general contractor and covers all parties on the project. There's also general liability insurance that covers claims of property damage or bodily injury caused by a contractor or their workers. It protects a contractor from legal fees if a customer files a lawsuit alleging property damage or bodily injury, and it pays any fees for defense from allegations of slander or libel. In many states, contractors are required to hold a certain amount of general liability coverage in order to get a contractor's license. Any errors in emissions insurance helps cover a contractor or design firm if they make a mistake in their professional services. This coverage is also known as professional liability or professional indemnity insurance. Contractors that also provide in-house design services will want to make sure they have this type of coverage. Inland marine insurance is a type of business insurance that covers materials, tools, and equipment while they are in transit to and from a job site. This coverage is meant to help protect business property that is movable or used for transportation purposes. While a builder's risk policy covers equipment and materials at the job site, inland marine insurance is used to extend that coverage to business property while it's on the road. You also have commercial auto insurance that covers company-owned vehicles and equipment from damages from motor vehicle accidents, theft, and vandalism. This type of coverage is required in every state when the company purchases a vehicle for an employee or owner use. Workers' comp insurance protects contractors against losses caused by work-related accidents or illnesses. It also provides the employee with benefits to compensate for lost work and wages. And in most states, workers' comp coverage is required for businesses with more than a certain number of employees. The actual number varies by state. Many states allow contractors to operate a self-insured plan as long as they meet the state requirements and obtain approval. Some states operate a state insurance fund from which contractors can purchase workers' compensation coverage. While state-operated funds can be more expensive than commercial providers, they can be a viable option for contractors who can't find coverage elsewhere. Pollution liability insurance is a policy that covers claims for bodily injury and property damage caused by hazardous waste or materials released during a company's business operations. Contractors that frequently work with or dispose of hazardous waste often need this type of insurance. This type of insurance covers contractors while working on a job and once the project is complete. In other words, if there is a problem with hazardous waste materials after the job is finished, this policy protects the contractor from liability issues. Subcontractor default insurance. This protects a contractor in the event of their subs failing to perform according to their agreement. Contractors may purchase it as an alternative to a performance bond or to provide additional protection beyond what a surety bond covers. On large commercial or public projects, general contractors are often responsible for managing dozens or hundreds of subcontractors and sub-subs. The larger the project, the greater the risk that one or multiple subs will fail to complete their work on time or according to specifications. Wrap insurance, as also known as wrap-up, provides liability coverage for an entire construction project or multiple jobs. Because it covers everyone on the job, contractors and subs may not need to provide their own general liability coverage. The policy can be written to include both general liability and workers' comp coverage, known as byline, though GL-only policies are increasingly common. A wrap policy is typically purchased as an OCIP. An OCIP is purchased by the owner, while a CCIP is purchased by the general contractor. Regardless of who purchases the policy, both generally provide the same coverage. Insurance coverage is available for nearly any type of risk in the construction industry. While some policies are required by the state or for particular types of projects, others can be tailored to mitigate specific risks faced by a contractor. Buying insurance can be expensive, especially for small companies, but it can quickly pay for itself with the first claim. Green building is the practice of creating structures and using processes that are environmentally responsible and resource efficient through a building's life cycle, from siting to design, construction, operation, maintenance, renovation, and deconstruction. This practice expands and complements the classical building design concerns of economy, utility, durability, and comfort. Green building is also known as a sustainable or high-performance building. Impacts of the built environment include green buildings are designed to reduce the overall impact of the built environment on human health and the natural environment by efficiently using energy, water, and other resources, protecting occupant health and improving employee productivity, and reducing waste, pollution, and environmental degradation. For example, green buildings may incorporate sustainable materials in their construction, either using reused, recycled content, or made from renewable resources. Create healthy indoor environments with minimal pollutants, such as reduced product emissions, and or feature landscaping that reduces water usage by using native plants to survive without extra watering. There are a number of reasons to build green, including potential environmental, economic, and social benefits. The Mercedes-Benz Stadium that you see here in Atlanta is a standout example of a sustainable sports facility. The $2 million square foot, $1.5 billion project was designed by Hawk, who worked with Burrow Huppold Engineering and Hoberman Associates to complete the stadium in July 2017. Perhaps the most incredible element of this LEED Platinum project is its commitment to be solar energy, with 4,000 solar panels placed not on the rooftop, but at eye level on ticket entryways and parking lot canopies. The panels generate enough energy to power 9 Atlantic Falcons games or 13 United matches. The design of Mercedes-Benz Stadium also features an impressive halo board at 350 tons and 58 feet high by 1,100 feet around the stadium's impressively massive video screen, as more than 63,000 square feet of LED lighting. In fact, all of the venue's lighting is LED, which lasts 10 times longer than standard lighting and reduces energy usage by as much as 60%. At the Georgia Sports Park Pavilion, the design team took a strategy that relied heavily on natural light, supplemented by smart LED lighting. Designed by Barnett Consulting Engineers and Ard plus Winter, the light level in the classroom was designed using less than 700 watts to artificial light. To optimize the efficacy of the lighting in the space, and after specifying high-performance light sources, light controls are used to further reduce energy usage. During the clear daylight hours, with all the lights on, the incident light can be as bright as 80-foot candles. However, when the foot candles increase beyond 40-foot candles, the light level photosensors reduce the light level to keep the classroom between 40 and 50 foot candles. The remainder of the spaces also have the appropriate amount of the LED light. The pavilion uses occupancy sensors which turn lights on or off in response to the presence of occupants. Keeping air moving is critical in sports facilities like gyms. The often colorful 5-blade Intramatic HVLS fans can be spotted at many gyms, rock climbing facilities, fitness centers, and more. Intramatic's downturn wingtip promotes airflow efficiency, funneling turbulent air away. Early helicopter blades had a flat end, but they found that the blade moves it as it lifts, so the tips fly up. Richard Huffard, director of engineering at Intramatic, told GBND, Intramatic's blades was designed to be relatively stiff, and they wanted the blade to stay as horizontal as possible without flexing throughout operation. They added downward winglets to reduce the wingtip vortice, allowing the blades to keep moving air down. Using Intramatic fans can create a perceived temperature change of about 4 to 7 degrees, which allows for a 3 to 5 degree thermostat adjustment in both summer and winter, with about 3% of energy savings per degree. Taken in total, these fans can help to save as much as 15% off a typical commercial space's energy bill. But building a truly sustainable sports facility means designing with green features in mind from the floor up. Rubber gym flooring like what you might find at the Anaheim Ducks training facility at 5 Point Arena in Irvine, California, or University of Michigan's Oosterbaan Fieldhouse is both durable and aesthetically pleasing, as projects like these worked with Rukopol. A standard Active Pro roll system from Rukopol is 24 millimeters thick and made up of a customizable underlayment and dense wear layer surface. You can choose from 3 underlayments, Plyo, Fitness, and Impact, and varying density and thickness. Each underlayment is engineered to absorb maximum shock and on impact, diminishing barbell bounce and easing joint stress, while simultaneously delivering ideal energy return. Environmentally friendly process where rubber tree sap is collected and then vulcanized to deliver superior shock absorption. The sustainably conscious flooring company also utilizes low energy production measures and recycles its woods waste to provide steam for milling, reducing its need for fossil fuels for safer training and drastically boosted performance. The Action Floors president previously told GBND that its maple flooring is what makes it truly stand out. In the U.S., maple is by far the preferred floor surface for basketball, volleyball, racquetball, squash, aerobic, dance studios, and even performance stages. Maple flooring is and always has been the core and is the only hardwood product we mill, specializing in maple flooring. He says the wood's light color makes it the leading choice, lending itself to superb gain line and graphics visibility. Cell structure of hard maple is also ideal, allowing for the flexibility a floor system needs to achieve high performance shock absorption and bounce. Good green design of a sustainable sports facility doesn't stop inside. And the aforementioned Mercedes-Benz Stadium in Atlanta, designed by Hawk, took its sustainable design principles outside and underground too, with an advanced stormwater management program that includes an on-site 2.1 million gallon stormwater vault, bioswales, and 680,000 gallon cistern for collecting and reusing rainwater for a cooling tower and irrigation. It's an incredible system that's combined with water-efficient fixtures, resulting in a 47% reduction in domestic water use. Things, as many know, have less negative impact on the environment than standard buildings. Their construction minimizes on-site grading, saves natural resources by using alternative building materials, and recycles construction waste rather than sending truck after truck to landfill. A majority of green buildings' interior spaces have natural lighting and outdoor views, while highly efficient HVAC systems and low volatile organic compounds or VOC materials like paint, flooring, and furniture create a superior indoor quality. Finally, green building materials, mechanical systems, and furnishings have become more widely available, and their prices have dropped considerably, in some cases below the cost of their standard counterparts. Integrating green principles into a building's planning and design process can generate 40% more savings and 40% better performance than simply adding green technologies to a traditionally planned and designed facility. Planning, designing, and constructing a green building isn't like installing new signage or adding a design feature at the last minute. If a company wants to stay within a standard budget and reap the full benefits of a sustainable building, all development decisions from the start must be guided by a green mindset. To launch a successful green planning and design process, it's important to hire the right project team members, your architects, your engineers, contractors, and consultants who are knowledgeable about the broad spectrum of green design and technologies and who have experience planning and constructing a variety of green facilities. Team members who are unfamiliar with green will often resist any deviation from standard design principles, building materials, and construction processes. They will make mistakes on everything from the amount of insulation needed to the selection of interior components like non-toxic flooring, therefore limiting the building's sustainability and having a negative impact on the budget. A collaborative green project team begins by examining the building site, the exterior and interior plans, and the budget, managing up from each planning decision's effect on the overall project. A green planning and design process was essential to the success of the 9-story, $112 million in Australian currency global headquarters for Lendlease in Sydney, Australia. The company wanted the building to set a new benchmark for energy efficiency and indoor air quality to increase worker satisfaction and retention, but it insisted on a standard budget. Also, the city had imposed heights and building density limits, so the building needed to have the greatest possible amount of usable space on each floor. One way the project team surmounted these challenges was by selecting a water-based chill beam air conditioning system. Although it cost 30% more to install than a standard system, the water-cooled system was 30% more energy efficient and took up less room between ceilings and floors, leaving more usable space on each floor. The team re-examined all of the other planned elements as well, replacing standard T8 lamps, for example, with more energy efficient T5 lamps with smaller housing units, was another way to save space, which helped reduce materials and construction costs. You should also look at choosing a sustainable site. If a building or business campus is going to be truly green, it cannot be constructed on prime farmland, parkland, or historic or prehistoric site, or the habitat of endangered species, nor can it be built within 100 feet of wetlands. Ideal locations for sustainable development include infill properties like parking lots and vacant lots, redevelopment sites like rail yards, and remediated brownfields. By choosing such locations, companies avoid contributing to sprawl and degradation of environmentally significant sites, often while being near services they need. The LEED rating program gives points to properties located within a quarter-mile of bus lines and within half a mile of rail and subway lines. The Genzyme Center is a 5-minute walk from a mass transit station. Approximately 25% of the building's 920 employees leave their cars at home. Do the math. To complete a successful green building on a standard budget, the project team must apply cost-benefit analysis to each component before allocating funding. For instance, a green roof costs more than a standard roof to install, but it brings a larger return on investment because it lasts years longer and provides more benefits, particularly stormwater management and lower energy costs. When DPR Construction planned its green regional office in Sacramento, California, used a proprietary software program called Ecologic to analyze the costs and benefits of each point and the LEED rating system for this building, as well as the cost to its own to operate. According to Ted Vanderlinden, DPR's Director of Sustainable Construction, the company weighed each possible LEED credit against the overall $6.2 million budget, projecting the cost and benefit of each credit as well as a 10-year return on investment. DPR found that approximately $85,000 of the $6.2 million would be spent on additional green upfront costs, including architectural and engineering design fees. Over the first 10 years, however, the 52,300 square foot office building will more than make up that $85,000 by generating $400,000 in operation savings. Cost benefit analysis should also incorporate the financial assistance and tax breaks and other incentives that more and more cities and states and utility companies offer to organizations that construct green buildings. Chicago, for example, awards floor area ratio density bonuses for downtown buildings that have green roofs. Since 2000, New York State's green building tax credit has given deductions against a company's or developer's state tax bill for projects that meet specific sustainable requirements. Make the site plan work for you. Site planning can minimize the amount of on-site infrastructure like roads and parking lots, reducing grading and other earthwork. Limit erosion and maximize your sediment control and provide easy access to public transportation, all of which will earn LEED points, lower construction costs, and reduce the facility and infrastructure footprint. Consider interior lighting. Typically, it makes up 20 to 25% of an office building's direct energy use, partly because heat generated by the lights leads to more air conditioning. Building orientation can create a daylit interior that needs much less artificial lighting, saving money both upfront and over the long run. And locations commonly subject to winds, buildings can be oriented to capture the breezes through rooftop clerestories and other windows that provide cross ventilation. Landscape, particularly in suburban locations, is another cost-effective green tool. It is especially good at minimizing heat islands, the buildup of heat from sunlight pouring into dark, non-reflective surfaces. West and south-facing building walls, for example, often become heat islands. Covering them with green screens, such as metallic lattices planted with vines or climbing flowers, will greatly reduce the heat island interior solar heat gain. Mature trees can shade building walls, roofs, and low-rise buildings, roads, and parking areas. A green roof landscape with drought-tolerant grasses and plants can lessen the heat island effect on a downtown building that is surrounded by many other buildings, each of which act as a heat island. The impact can be dramatic. Designed for greater green, companies can use a wide variety of techniques to cost-effectively design a green building. A long and narrow building shape, for example, maximizes natural lighting and ventilation for workers. Locating fixed elements like stairs, mechanical systems, and restrooms at the building's core creates a flexible and open perimeter, which also allows daylight to reach work areas. Operable windows and skylights enable natural ventilation in temperate weather. Windows with low emission glazing minimize interior solar heat gain and glare. The LEED Platinum Business Center in India, the greenest building in the world when it was completed in 2003, was given a circular design that brings sunlight to every part of the 20,000 square foot building. During the day, artificial lighting is not used in 90% of the Green Business Center. Thanks to its green design and energy efficient technologies, it uses 55% less energy than a standard building of similar size. Green building technologies help conserve and even generate energy. Companies can, for example, install motion sensitive light sensors and individual climate controls in offices at workstations. They can also purchase highly efficient HVAC systems that don't use chlorofluorocarbon halon-based refrigerant, which depletes the ozone and requires more energy than green refrigerants. Such technologies cost more upfront than standard building systems, but custom companies and developers can stay on a mainstream budget by taking advantage of the growing number of incentives and landing opportunities offered to companies installing building systems that save energy in the long run. Advanced energy conserving systems and many other green features took up. Green facilities can also produce some of their own electricity with alternative technologies. Save and manage water. As water becomes scarcer and more expensive in many parts of the world, firms need to focus on conservation. They can install water-conserving irrigation systems and plumbings, waterless urinals, which are more sanitary than standard ones, and native and drought-tolerant landscape plants. And they can use recycled, not potable water for landscaping needs. Many jurisdictions have stormwater management regulations that property owners must satisfy to limit the risk of flooding and heavy rain and reduce pollutants like motor oil and fertilizer that are swept into stormwater. While an undeveloped site is able to absorb a significant amount of rainfall, impermeable surfaces like buildings and parking lots greatly increase the amount and speed of stormwater flowing through and off the site, raising the risk of flooding. Green roofs and man-made retention ponds and wetlands are other effective stormwater management tools that can also beautify and add value to a property. Green building materials create a healthier and safer workplace for employees. According to a 2002 study by the Indoor Environment Department at the Lawrence Berkeley National Laboratory in California, approximately 23% of U.S. office workers experience 2 or more sick building syndrome or SBS symptoms, such as dizziness, nausea, and acute eye, nose, and throat irritation in their workplace annually. Same study found that the improved air quality generated by the use of green design, building materials, and technologies lowers SBS symptoms by 20 to 50%, while colds and flu are reduced by 9 to 20%, and allergies and asthma drop by 8 to 25%. Green buildings are hardly a U.S. phenomenon. In fact, several European countries, particularly the United Kingdom, many types of sustainable non-toxic building materials are now readily available at reasonable prices. These include low and zero VOC paints, straw board made from wheat rather than formaldehyde-laced particle board, and linoleum flooring made from jute and linseed oil rather than standard vinyl, which is packed with toxins. Materials like 100% recycled carpeting and heavy steel, acoustic ceiling tiles, and furniture with significant recycled content and soybean-based insulation often cost the same or less than standard materials and have much less impact on the environment. How you build is just as important as where and what you build. Achieving a superior indoor air quality, for example, starts during the construction process. By coordinating wet and dry activities, construction crews can avoid contaminating dry materials with moisture and making them breed grounds for mold or bacteria. Mechanical ductwork can be protected from a project site pollutants if it's sealed in the factory before shipment and kept sealed during its install. Recycling construction waste is part of the green process that brings several benefits. First, the waste is not dumped in a landfill. Second, recycling costs are often much lower than landfill fees. Finally, by crushing the concrete and asphalt from a demolished facility and using it as structural fill for a new building on that site, a company can save hundreds of thousands of dollars because it doesn't have to ship that waste off-site and buy gravel for structural fill. LEED gives points to every project that recycles at least 50% of its construction debris. Many companies do more. As green goes mainstream, standard buildings will rapidly become obsolete and lose value. To avoid this problem, building owners should carry out green renovations. The LEED CI program for commercial interiors offers guidelines to convert any standard workplace into a green building by generally following the same 10 rules that apply to new construction, such as selecting alternative building materials. A green renovation can include everything from a new green roof to more efficient HVAC and lighting system and large existing windows and low VOC paints and floors. The green futures here, like the dramatic occasional unsettling and ultimately beneficial transformations wrought by the introduction of electric lights, telephones, elevators, air conditioning, green building principles are changing how we construct and use our workplaces. Armed with 10 rules discussed above, corporations no longer have an excuse for eschewing sustainability. They have tools that are proven to lower overhead costs, improve company productivity, and strengthen the bottom line. These are just a few questions that you might consider when, as you're reviewing for the chapter and the test. And these are